Hello everyone, Ashutosh here, back again with some exciting stuff for you guys. तो आज हम इस वीडियो में बात करने वाले हैं बायोमैकेनिक्स के एक बहुत इंपॉर्टेंट टॉपिक के बारे में जो कि है एंगल ऑफ पुल। तो इस वीडियो को शुरुआत करने से पहले अगर आप इस चैनल पर नए हैं तो सब्सक्राइब कीजिए, हिट कीजिए नोटिफिकेशन बेल ताकि आप ऐसी कोई भी अपडेट्स मिस ना कर सकें। वीडियो को लास्ट तक ज़रूर देखिएगा बिकॉज हाफ नॉलेज इज़ वेरी डेंजरस। सो लेट्स स्टार्ट। So our today's topic is angle of pull. Angle of pull is a very important topic as far as biomechanics is concerned. So we will see what is angle of pull and in various cases how it looks and how it works. So let's start. Here it is written that if the muscle is inserted at right angle to the bone, then the efficiency is the highest. Means if the bone is inserting at the right angle, means supposingly if this is the bone and if it is inserting at the right angle to it, if the muscle is inserting at right angle, then the efficiency of the pull is highest. So that is written in the first point. So if the muscle is inserted at right angle to the bone, then the efficiency is the highest. Whether the angle is more than 90 degree or less than 90 degree, then its efficiency reduces in both the cases, whether it is an obtuse angle or whether it is an acute angle. Means in both the cases the efficiency reduces, but it is higher in case if it is 90 degrees. Next, it is written, or we can say the definition of the angle of pull is this: the angle formed between the line of pull of muscle from the insertion and the longitudinal axis of the bone in which the muscle is acting. What does this line signifies? We have discussed recently that if we suppose this is the longitudinal axis of the bone and this is the axis for the muscle insertion, then we can say that the angle formed between these two here, this is the angle of the pull. So that is written in this sentence or this line, that angle formed between the line of pull of muscle from the insertion and the longitudinal axis of the bone in which the muscle is acting. So this is what the angle of pull is telling us. Next we will see in different cases how the angle of pull works. So here in the first case we can see that this we have taken as the longitudinal axis of the bone and the muscle is getting inserted at the very 90 degree to it. So the theta here is 90 degrees. As we have said that there are three cases: 90 degrees, less than 90 and more than 90. So as we have said earlier that at 90 degree the efficiency of the muscle is highest to pull at that angle. So here it is written that when the angle of pull is 90 degrees, all of the muscular energies is going into rotation or rotatory component. There are various components here. So one is rotatory component and it is always drawn perpendicular to the longitudinal axis of the bone. So rotatory component is this, which is always drawn 90 degree to it. So here the muscle is also getting inserted at 90 degree, so the efficiency is very high. All the forces are going perpendicular to the bone, so all the forces are going perpendicular, so we are getting a very high efficiency or high muscular energy. And in this case we get 100% rotatory component or 100% rotatory component here at theta 90. So this is the very first case of the angle of pull. The next case in the angle of pull is this, having theta less than 90 degrees, which is forming an acute angle. So here we have two components. One is the rotatory component and the next one is the stabilizing component. So one is the rotatory and next is the stabilizing component. So here we are having theta less than 90 and we are having the sum of stabilizing and the rotatory component. In this case the angle is this, which is always drawn on the joint side. We will see the most important points to remember in the angle of pull. So the angle is always drawn on the joint side. So this is the joint. So at the joint side we will always draw the angle, and this is actually the angle. So you can see that we are getting an obtuse angle altogether. Sorry, I meant to say an acute angle altogether. You can see here we're getting an acute angle less than 90. So this is the rotatory component and this is the stabilizing component. If you carefully look at it, then you will come to know that here the principle used is the triangular law of vector addition. So I will draw and make you understand what is this. As we have seen, the triangular law of vector addition works like this. This is one, let's supposingly say PR vector. This is another vector, that is maybe QS vector. So this is forming another PS vector. So this is how it works. Here we have two displacement vectors by side in the triangular law of vector addition, giving us a resultant displacement vector, which is this. So the same principle is used here also. Actually, they are the resolution of forces which we have used here. These are all the resolution of forces. This vector, these are all the resolution of forces which is giving us this resultant. Or we can say the muscle pull in this direction. So this is actually the resultant of it. So here the concept uses the triangular law of vector addition. So this is all about the case 2. Next we will see the case 3. In the case 3, we have theta more than 90 degrees, which is actually making an obtuse angle altogether. So this is an obtuse angle. Here we can see this is the obtuse angle. Here will be the muscle pull, and from here the longitudinal axis of the bone. So we are getting an obtuse angle altogether. So this is how we get the obtuse angle, this way, more than 90 degrees. So here we have two components. One is the rotatory component and the next one is the dislocating component. Okay, one is the rotatory and one is the dislocating component. In the previous case, we have seen that there are two components, rotatory as well as stabilizing, not the dislocating. Here we have dislocating and not stabilizing. In this case, instead of stabilizing, we have dislocating component plus rotatory component. So these two components makes this case of theta more than 90 degrees. In this case also, the triangular law of vector addition is used to get the resultant. If we carefully look at it, I have not drawn the resultant, but you can see this is the rotatory, this is the dislocating. If I draw the resultant from here, you will get this resultant. So the angle muscle pull will be in this direction, giving you an complete triangular law of vector addition resultant. So these are the three cases in which the angle of pull works. The case 1 was theta 90 degrees, case 2 was theta less than 90 degrees, and case 3 was theta more than 90. So in all these cases, how the muscle efficiency is there and in which case we got the highest efficiency, we have discussed it all. Now at the last, I want to make you aware to some points as far as angle of pull is considered. So here are some points you have to note when you are studying the angle of pull. First is, always draw the angle on the joint side. As we have discussed, we have to draw angle always on the joint side. Like in this case, if we have seen this, this is the muscle, and say if this is the resultant and this is the angle. So this is a joint. So on the joint side you have to, this is the angle. So at the joint side you have to make the angle. So this is what this point is saying. Always draw the angle on the joint side. Next is the key words for the RC means the rotatory component, SC means the stabilizing component, and dislocating component is DC. RC, SC and DC. So these are the very three components used in all the three cases of the angle of pull. Last one is, last but not the least, rotatory component is always drawn perpendicular to the longitudinal axis of the bone. We have seen that in all the three cases, the rotatory component is drawn perpendicular to the longitudinal axis of the bone. So this is very important point to note in all the three cases while drawing all three cases. So this is all about the angle of pull. I hope you are cleared with all your concepts regarding the angle of pull, which is a very important topic in case of biomechanics. If it is so, then please give it a big thumbs up and share as much as you can. अगर आपने अभी तक मेरे चैनल को सब्सक्राइब नहीं किया है तो प्लीज़ कर दो और नोटिफिकेशन बेल पे हिट कर दो. You can also follow me on various social media handles, links down in the description box. For more such quality content, visit to my channel and enjoy watching the videos. One more important thing, अगला वीडियो आप किस टॉपिक पे चाहते हैं आप कमेंट्स में लिख सकते हैं. मोर द लाइक्स आई विल मेक द वीडियो ऑन दैट. मिलते हैं अगले वीडियो में, लाते हैं नए टॉपिक्स. टिल देन keep watching, keep sharing my videos. So until next time, stay safe, stay tuned.